This video is going to talk about transformations with quadratics and graphing. So we've been talking about quadratics for about the last 3 weeks or so. So your original graph always starts off with y equals x squared. That's the whole point, is that the squared, or the exponent of 2, is what makes it a quadratic. And this is what's called your parent graph, or your original function. That's what you're starting off with. And what we're going to focus on is all the other pieces and parts of it are what move the graph and affect it by shifting it or shrinking it or stretching it. And they're made from this parent graph, or this original function. And we've talked about this before in the beginning of the year with absolute value functions. So we know that h is what shifts it in the x direction, or your horizontal shift. Your k is your shift in the y direction, or your vertical shift, up and down. And a is your vertical stretch, or your vertical shrink. So what you want to keep in mind is that if a is a fraction, like if a is equal to 1/2, then it's going to be wider. And if a is a whole number, something like 2, then it's going to get skinnier. Okay, so that's all telling you what it is equal. Now this is your original graph here. I've given you the picture, x squared. So you know things by looking at it. There's nothing there. The vertex, for instance, is 0, 0, and it doesn't have any stretch or any shrink with it whatsoever. So I've given you here some really straightforward objectives, some things that I want you to keep in mind, what I need you to be able to do. So if I give you this graph, you need to be able to look at it in vertex form and describe for me in words what's happening here. So x squared minus 4. Okay, the minus 4 is not inside the parentheses, it's outside. So if you describe for me this transformation, it's move the parent graph down 4. That's what I need you to be able to tell me. Okay, I've gotten a little bit more complex here. I've given you a number out front, and it's negative, so it's reflected across the x-axis. Okay, the negative is what tells us that. Because it's 2, I know that it's skinnier. Okay, inside the parentheses, it's plus 4. Okay, if we think of what our vertex is here, okay, our vertex would be a negative 4 and a negative 5. So what we're thinking is that it's being shifted down 4. And negative 5, negative 4 is our shift in the x direction, so that means it's left 4. And our 5 is in the y direction, so that means it's shifted down 5. Okay, and the last one here we're going to describe in words. Okay, it's positive, so we're not reflecting at all, but it is wider. Okay, because it's half. Okay, the vertex here, you can say to yourself, is a positive 3, positive 2. So in the x direction, okay, we're moving 3, so we're going to the right 3, and we are going up 2. Okay, so that's our first objective. Our second objective is being able to match the equation with the graph. Okay, so I've given you 3 equations and 3 pictures. So what we're looking at here is this equation. I can tell by looking at it is the only one that has a positive a value that's going to be facing upwards. So I know this is the one that should be C. Let's make sure it also makes sense. When I look at this vertex, it's negative 5, negative 3, or it's shifted to the left 5 and down 3, so I know this right here is graph C. Okay, these ones over here, okay, let's think about what this vertex is here. Okay, the vertex is a positive 5 And then it doesn't have anything outside the parentheses, so that means the y value is 0. And then for this one, I'm going to write over here so I have some more room. Okay, my vertex is going to be a -2 and a -4. Okay, so this is going to be A, where my vertex is 5, 0, and this one is going to be B, where my vertex is -2, -4. Okay, so being able to match up those transformations with the appropriate graph. That's our second objective. And then our third objective is being able to read a transformation in words and then being able to write the equation or match it to an equation or match it to a graph. So the parent function f of x is equal to x squared is translated 5 units down, 2 units to the right, and reflected across the x-axis. What is the transformed function? So if I'm going 5 units down and 2 units to the right, okay, I gave you this graph so you could kind of use it to work from. F of x equals x squared starts here. So 5 units down and 2 units to the right would be here. Okay, so we would start here, then we move here. Okay, but then we're going to reflect across the x-axis, and I'll switch colors for this. So now I'm here, and now I'm going to be facing down. That's the whole idea. So what is the transformed function? So I use that to be able to move from here to here, then reflect it across the x-axis to go here. So I'm saying to myself, I know I'm facing down, so I know it's going to start like that, and now my vertex of this is 2, 5. So it's x minus 2 plus 5. So in a multiple choice problem, you'd be matching that with the graph or matching that with the equation, but it's really helpful to be able to draw in the graph and physically move it yourself. Okay, we have one more example problem like that we're going to try. The parent function y equals x squared is translated 3 units down and 4 units to the right. So I started here, now I'm here, and now I'm reflecting across the y-axis, so I'm going this way. So 1, 2, 3, 4, 1, 2, 3, 4, so now I'm here. But I'm still facing up. Okay, reflecting across the y-axis means I'm still facing up. So what is the resulting function? Well, I'm facing up, so I know I have a positive a. So what is my vertex? 1, 2, 3, 4. So that's a -4 is my x value. My y is 1, 2, 3. So x plus 4 minus 3. So this was just some practice with transformations. Most of this we've done before. Go ahead and use this to help you with your homework assignment. If you have questions, please come into CAV Morning.